Hello, welcome to the fourth unit, Multivariable Differential Calculus and Function Optimization. In this video, we are going to see what is meant by total derivative and some problems on total derivative. Let us see first the definition. Let u is a function of two independent variables x and y, where x is once again a function of t and y is also once again a function of t. Now, if you substitute this x and y here, right, then this function, which is earlier a function of two independent variables, becomes a function of variable t, because x and y are functions of another variable t. So, if you substitute these two here, then u is a function of t alone and is called composite function of a single variable t. And because u is a function of t only, therefore it acts as a ordinary derivative. So if I want to calculate du by dt, then the formula is dou u by, first with respect to x, dou u by dou x into what is x? X is a function of t. So dx by dt plus dou u by dou y. Next, y is another function of t, therefore it is dy by dt. So this is called the total derivative of u. So which is known as the chain rule. Okay, so we'll see this with one example here. Problem: find the value of du by dt. Given u is sine of x by y, where x and y are some functions of t. So clearly, if you substitute this x and y here, this sign becomes sine of e power t by t square, which is purely a function of t. Therefore, u is depending on a single variable t. Therefore, you can calculate du by dt. It acts as a ordinary derivative. That's why this du by dt is coming here. So now how to calculate this du by dt? So now we will use this chain rule here. See here, x is a function of t, y is another function of t, which is like phi of t and psi of t, and our f of xy is here sine of x by y. So to calculate this du by dt, we are using this chain rule. So according to the chain rule, du by dt is nothing but dou u by dou x into dx by dt plus dou u by dou y into dy by dt. So dou u by dou x, partial differentiation of u with respect to x is sine of x by y becomes cos of x by y. For internal function with respect to x, for x by y it is 1 by y. Next, dx by dt. dx by dt is e power t is e power t plus dou u by dou y with respect to y, cos of x by y. For x by y with respect to y, minus x by y square. What is dy by dt? 2t it is. Now cos of x by y, 1 by y as it is. So this we taken out common. Cos of x by y is appearing in both terms. 1 by y is also common. Then left over is here e power t minus, what is left over? 1 by y is gone. So what is left over? Minus 2t x by 1y is there. So cos of, now I am replacing x and y with e power t and t square. So e power t by t square, 1 by t square, e power t minus 2t, x by y is e power t by t square. So if you simplify this, what happens is e power t, I can take out common here, e power t, and cos of e power t by t square is outside. Then what is remaining is here 1 minus 1t is cancelled here. So 2 by t it is. So this t square enters and it becomes t cube. So this is what du by dt. Now the same composite function, the same rule is extended for three functions. Suppose u is a function of three independent variables x, y, z, where x, y and z are some functions of t. Then by chain rule, du by dt is nothing but dou u by dou x into dx by dt. Next, dou u by dou y, second variable, into dy by dt plus dou u by dou z into dz by dt. So this is the chain rule. Now we'll see a problem based on this. So u is a function of three variables x square plus y square plus z square, where x, y and z are functions of variable t, right? So x is e power 2t, y is e power 2t cos 3t, z is e power 2t sin 3t. So he is asking find du by dt as a total derivative. So according to the formula, du by dt is this one. So that is we written du by dt. So first I have to calculate dou u by dou x. What is dou u by dou x? 2x. So if you see here, dou u by dou x is 2x. Next, dx by dt is e power 2t into 2 plus dou u by dou y is 2y. Next, dy by dt. So dy by dt means I have to apply product rule. So e power 2t as it is for cos 3t minus sin 3t. For 3t it is 3 plus cos 3t as it is. For e power 2t into for 2t it is 2 plus next dou u by dou z. Dou u by dou z is 2z. Next, here once again the product rule. E power 2t as it is for sin 3t cos 3t into 3 plus sin 3t as it is for e power 2t into 2. Now I have to simplify this entire thing. So what is the simplification of this? 2 into 2, 4 e power 2t, but x is what? E power 2t. So e power 2t into e power 2t, e power 4t. In the similar way, if you 2 y is e power 4t into cos 3t, and if you simplify this, here common is e power 2t into e power 2t. This comes outside and y is e power 2t cos 3t, therefore it becomes 4t. So similarly here e power 2t comes outside, whereas z is what? E power 2t sin 3t. So z is what? E power 2t sin 3t. This 4t is coming because we are taking out this e power 2t. So now 4 e power 2t. So what is common in all this? 2 e power 4t is common. So cos 3t into 2 cos 3t is 2 cos square 3t. This into this is minus 3 sin 3t cos 3t plus here this is common. So sin 3t into 3 cos 3t here plus 2 sin square 3t. Okay. Now 2 cos square 3t plus 2 sin square 3t, it becomes 2 minus these two gets cancelled. So 2 into 2, 4. 4 e power 2t. 4 e power 2t already it is there. So it becomes 8 e power 4t. Now another formula, same thing, composite function. If z is function of xy, where x is, earlier it is a function of single variable, now x is also a function of two variables u and v, and y is also a function of two variables u and v. Then by chain rule, because if you substitute instead of x and y, this function f, which is earlier in terms of x and y, now it becomes a function in terms of u and v. Therefore, there is no question of ordinary derivative here. So partial derivative will come into the picture. So dou z by dou u I have to calculate. Similarly, dou z by dou v I have to calculate. So dou z by dou u is equals to dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u. In the similar way, dou z by dou v equals to dou z by dou x into dou x by dou v plus dou z by dou y into dou y by dou v. The same rule it is extended here. Earlier it is x and y are functions of single variable. Now they are functions of two variables. That is the only difference. So because of this, there is no question of getting ordinary derivative anywhere, because every time it is depending on more than one variable. Therefore, completely the partial derivative will come into the picture, right? So now we'll see one problem. If x is r cos theta, y is r sin theta, prove that what he is asking is x into dou u by dou x plus y into dou u by dou x plus this entire thing is equals to r into dou u by dou r plus dou square u by dou theta square. We have to show that. So here u is a function of x and y only. That is, u is function of x and y, and given that x is r cos theta, y is r sin theta, which means x and y are functions of r and theta. So u is a function of xy and x and y are functions of r and theta. Therefore, now I can use the chain rule of composite function. So I want, because if I substitute x and y here, this becomes a function of r and theta. So first dou u by dou r. So according to chain rule, dou u by dou r is dou u by dou x into dou x by dou r plus dou u by dou y into dou y by dou r. So dou u by dou x is as it is. Dou x by dou r, partial differentiation of x with respect to r is cos theta, plus dou u by dou y as it is. Dou y by dou r, partial differentiation of y with respect to r is sin theta. Similarly, dou u by dou theta, the formula is dou u by dou x into dou x by dou theta plus dou u by dou y into dou y by dou theta. This equals to dou u by dou x as it is, dou x by dou theta, this one. With respect to theta, this becomes minus r sin theta. Next, similarly, with respect to theta, this becomes r cos theta. So we got dou u by dou r, dou u by dou theta. So from this, dou by dou theta, if I want dou by dou theta, right? So it becomes like this, minus r sin theta dou by dou x, this u is not in the picture, plus r cos theta dou by dou y, this u is not in the picture. Suppose if you operate with u on both sides, you are going to get this one only. So this is what dou by dou theta. Now I want dou square u by dou theta square. This I can write it as dou by dou theta of dou u by dou theta. Okay. So dou u by dou theta, we already know this is dou u by dou theta. So this entire thing I have to do the partial differentiation with respect to theta. So dou u by dou theta is written here. What is dou by dou theta from 3? This one, minus r sin c. Dou square u by dou theta square, we are writing it as dou by dou theta of dou u by dou theta. Dou by dou theta, this value is from 3, this one. Dou u by dou theta from 2, this is dou u by dou theta, that is written here from 2 and 3. Now we have to simplify this one. Minus r sin theta into this, r minus into minus plus r into r square sin theta into sin theta sin square theta. Dou by dou x of dou u by dou x is dou square u by dou x square. In the similar way, if you multiply, you will get these 4 terms, right? So now if you simplify this, r square sin square theta dou square u by dou x square. So this becomes minus 2r square plus r square cos square theta dou square u by dou y square. So because these two are same mixed derivatives, so we got this one. So this is what he is asking. So now dou square u by dou theta square plus r into dou u by dou theta. So r into dou u by dou r is this one from 1, and this is 4. From 4 we got this. So if you simplify this one, r cos theta into dou u by dou x plus r sin theta dou u by dou y, this entire expression as it is. So r cos theta is x dou u by dou x, r sin theta is y. So r square sin square theta is y square. So like that, we'll get that result. So if you look at the next problem, u equals to e power y minus z, z minus x. So here clearly f is a function of x, y, z. So I have to prove that dou u by dou x plus dou u by dou y plus dou u by dou z is 0. So this is given. So what I am taking is y minus z, I am taking it as capital X, z minus x as capital Y, x minus y as capital Z. Then u becomes a function of x, y, z, capital X, y, z. So by chain rule, dou u by dou x equals to dou capital X equals to dou u by dou capital X, right? Because x, y, z, if I substitute all this, this becomes a function of small x, y, z. Therefore, dou u by dou small x is dou u by dou capital X into dou capital X by dou small x. So using the chain rule. So now, dou u by dou capital X, what is u? Dou u by dou x as it is dou u by dou x. Dou capital X by dou small x is dou capital X by dou small x is 0 because there is no x here. So that is 0. Similarly, dou u by dou y as it is dou capital Y by dou x. So dou capital Y by dou x is e power z minus x. For z minus x is e power, for z minus x it is 0 minus x minus, right? Similarly, dou u by dou z e power x minus y. So if you simplify, you will get this one. Similarly, you can calculate dou u by dou y, dou u by dou z. So if you add all these three after cancellation, you will see it is 0, right? So this is very simple. So I am Srikanth Reddy. Thanks for watching. I will see you in the next video.